earlier over here to k, okay, because it's a half here. Okay, so that's effectively what we're saying here. And when it comes to model limitations, you'll sometimes get a question to say, what are the restrictions of this model, etc. So some key points is that exponential growth cannot continue forever, okay? So if you think about it, there's eventually going to be limits to resources in reality, right? So as t increases, there's always going to be limits there. Okay, and when it comes to negative values, for instance, drug concentration, that concentration cannot go below 0. Okay, so your model might be spewing out negative values even though your t is increasing. Okay, and obviously a constant rate parameter k. Okay, well k is a constant. This parameter may change over time in reality, right? It's not always going to be guaranteed that it's going to be there. Okay, so that's why it's important to have a general understanding of certain model limitations that can occur. These are usually just like one or two marks, but still important to know, just as it helps you to get marks where you otherwise might slip up, right? So without further ado, let's get to some exam style questions. And again, these are based off nearly all the kind of exam questions I could find in the past papers. These are based to be very similar to those questions. So let's get into them. Alright guys, so for number 1a, we need to show that the equation 2 log 5 3x minus 1 is equal to this can be written as 9x squared minus 16x minus 4 is equal to 0. Right, so a few things here. How do we even start? Well, there's a few things we could do. But the thing is, remember what we need to do when we've got logs, okay? There's a few things I can spot out immediately. Or just an equation in general. Whenever we have an equation, we need to get points, or we need to get what we're trying to solve to one side and get the constants to the other side, right? Because that way we can solve the equation. So let's go with that principle. So the way we can do that is I can say, well, look, I can say that we have log 5 3x minus 1 squared, okay, vis-a-vis the power rule. And that's going to equal 1 plus log 5 2x plus 1. What I want is the log 5s on the one end and the 1 on the other. So I'm going to say, well, log 5 3x minus 1 squared, okay, minus log 5 2x plus 1 is equal to 1. Interesting. But now I'm stumped because I've got two logs, can't minus them, and it equals 1. So what do I do? Well, think about it. I've got the log rules here from which I can apply log 5 3x minus 1 squared over 2x plus 1 is equal to 1. Okay? Simply by using our log rules here. And then remember what we did before when we had, say, ln x is equal to something like 6. Well, if we raise it to a power of e, then we can get x is equal to e to 6. So maybe that works here. Maybe I can say that e to the log 5 3x minus 1 squared over 2x plus 1 is equal to e to the 1. But that doesn't really make any sense now because we're stumped. We've got e to the log 5, but that doesn't help me. It doesn't break down into anything. So what can I raise it to that's going to simplify this question? Well, what I can raise it to is 5. Okay, I can raise it to 5. Why? Because just like e cancels it here, because we have ln x, its inverse, we have 5 to the x, and its inverse here, log 5. So that's going to cancel. So therefore, what can I say, guys? Well, I can say that 3x minus 1 squared over 2x plus 1 is going to give me 5. Which means that 3x minus 1 squared is equal to 5 times 2x plus 1. Now this is looking a lot easier. All we have to do from here is get it to this. And that's pretty easy. Right, I can just multiply it out. 9x squared minus 6x plus 1. Okay, it's going to equal 10x plus 5. Which means then 9x squared minus 16x minus 4, okay, is equal to 0. And that's exactly what they wanted. Okay, so let's go over how we did that again. What they want, okay, is to put this into this. So we need to say to ourselves, okay, cool. We can take the 2 over and make it squared. And as with any equation, we need to get the variable on one side and the constants on the other. So that's what we did here. Variables and constants. But then we're stumped because we can't minus it, so we're going to convert it now into a singular log function via our log rules. Okay? Then we're like, we can't just raise it, we can't just put it as a power of e because this isn't ln x. It doesn't work the same way. But what made this method work was the fact that e and ln x are opposites. So what's the opposite here? Well, the opposite is 5. So we raise it to the power 5, raise it to base of 5, I mean, and we just simplify from there, and we get our answer. Alright guys, now for number B, this is a pretty simple one. I don't know why it's 4 marks, should really be like 3. We just have to solve this, because it says, hence solve the equation, which is basically this, showing clearly that there's only one valid solution. Well, I'm going to say is we have 9x squared minus 16x minus 4 is equal to 0. Okay. Now if we do 9 times negative 4, okay, that's going to give me negative 36. What can negative 36 be broken down into? Well, remember, whenever we're breaking down something like this, we go via prime factors. So that is like 2, 3, 5, 7, 11, etc. Okay, because that's going to help us find factors here. So if we do 2, well, what is multiplied by 2 to get to negative 36? Well, that's a negative 18. And what is negative 18 plus 2? Well, that is negative 16. So therefore, these satisfy this. So 9x squared. Okay, then I'm going to simply say 9x squared minus 18x plus 2x. Okay, minus 4 is equal to 0. So if I take out 9x here, guys, I'm going to get x minus 2 plus 2, x minus 2 here. Okay, so as you can see, we now have a common factor of x minus 2, which means I can do x minus 2, 9x plus 2 is equal to 0, x equals 2, or x is equal to negative 2 over 9. Or is it? Because, think about it, if we have a negative here, going into our original equation, we can't have a negative log, okay? So if we put in x is equal to negative 2 over 9, that doesn't make any sense. Okay. Negative 2 over 9 here doesn't make any sense. We can't go smaller than 0 in the log. You simply can't have a negative in there. So we can say it can't equal that. Therefore, x is going to equal 2. That's going to be your answer. Alright guys, so for number C, okay, for number C now it says, using your answer to part B, or otherwise, solve 2 log 25, 3x minus 1, is equal to half log 25, 2x plus 1. Okay, interesting. So they want us to solve 2 log 25, 3x minus 1. Okay, is equal to a half plus log 25, 2x plus 1. Okay, cool. So, now this is an interesting one, because how do we go about doing this? Well, I don't know where to start, so let me just get this to the same point we did last time, right? And that is putting the variables on one end, putting the constants on the other, right? So I can basically say log 25 x minus 1 squared minus log 25 2x plus 1 is equal to a half. Okay? So I still don't know what to do, so I'm going to simplify it down. So log 25 3x minus 1 squared over 2x plus 1 is equal to a half. Cool. Now what do I do? Well, what does it want? Hence or otherwise. So this is interesting, because if we were to raise this to the power of 25, we'd get 25, root 25 on this end, right? And that's going to be super difficult to solve. Think about it. We have our equation here, and we get root 25, that's going to be an ugly equation. And in many cases, we're not going to be able to use a calculator. Okay, so we wouldn't be able to use the quadratic formula properly. So we could be wasting tons of time in the exam. So how do we come out of this problem? What formula can we use? Well, remember our change of base formula. Log 25 of something, z, is equal to log z over log 25, right? This is log 10 base. We could say ln as well. Okay. So, what does that tell me? Well, it could be any base we could use here. And we know that it says to, using your answers as part B, where we had base of 5, that makes me want to use a base of 5. So let's do that. Okay, so let me get rid of this. Get rid of it. And I get rid of the z. Because I can say that what we then have is 3x minus 1 squared over 2x plus 1 over here. Okay. And, or better yet, I don't want to write it twice. I'm going to say let's z equal that number, okay? Cool. But now there's another issue. What is that issue? Well, we have log 25 here, and we don't know how do we break that down? Well, we can say that that's going to equal 5 squared, right? And then what can we do? Well, we can say that we have log z over 2 log 5. Interesting. So, what does that give us? Well, that gives us now a value, okay, of saying, well, look, we're going to have a half log 5 3x minus 1 squared 2x plus 1, okay, over log 5 is equal to a half. These are going to cancel, obviously. So we're left with log 5 is equal to 1. But now, how do we solve this? Well, we ask ourselves, what value must 5 be risen to get to 5? That value is 1. Okay. So what we're left with is the same equation as before. Log 5, 3x minus 1 squared over 2x plus 1 is equal to 1. And that was the same thing as what we did before. Okay. And we solved that. We got x equals 2. So therefore, I'm simply going to say that x equals 2. Okay, we've already solved it. And that's it. So how do we go about doing this again? Okay, because this is a classic scenario where you're not allowed to use a calculator and you need to use the change of base formula. What we did here was we simply, again, we put it into a form we could understand. Variables on one side and the numbers, the constants on the other. Log 25 z is equal to half. We then know that using change of base, we can say that log 25 z is going to equal log 5z. It could be ln. We could use log 10. We could use log 10 million. But remember, we need to use log 5 because that's going to help us actually solve this problem. Okay, because we already know log 5. Okay, so we put it in terms of log 5. So log 5z over log 5, 25, which 25 is actually 5 squared. Okay, so good, we're getting somewhere. We can then take the 2 down. So we get a half, okay, of log 5z over log 5. The halves cancel. And we know that log 5 is 1. And so we're left with what we originally got, which means if we're left with what we originally got, our answer is what we originally got, which is x is equal to 2. Alright guys, so these ones now are actually a bit of fun. Okay, just a bit of algebraic manipulation. Again, at the moment, these are obviously, yes, UCAD Excel, and these are paper 2 for IAL. But they can pop up in paper 3. But we'll do the graphs later on. They're going to come soon, but later in the video. And that will be mainly for IAL paper 3. And obviously UCAD Excel, that's continued as well. So, but these are still exam style questions. So these aren't basic questions. These are based off exam style questions. So we're told that given that log 3.2 is equal to P, and log 3.5 is equal to Q, express each of the following in terms of P and Q. So log 320, okay, we know that the bases are the same here. Okay, great. That works. So log 320, let's break that down into some factors here. prime factors. 20. We've got 2 times 10. We also have 5 times 4. Okay. Considering that we have log 5 here, I'm going to go for the 5 times 4. So, we can say that is equal to log 5 times 4 here, which gives me log 3, 5 plus log 3, 4. Okay. Now the question arises, what is 4? Well, 4 is simply two squared. Okay. Which means that we have log 3, 5 plus 2 log 3, 2. And now we're going to ask ourselves, what's log 3, 5 and log 3, 2? Log 3, 5 is Q. Log 3, 2 is P. So therefore, what we get is Q, okay, plus 2P. That's your answer for number I. Okay, so what do we do here? We recognize that 20 can be broken down into prime factors of 5 and 4. We could use 2 and 10, but considering I already had, well, I mean, to be fair, you could have used this, it would have been fine. I just wanted to use 5 and 4. Okay, so log 3, 5 plus log 3, 4. Okay, using our rules. And 4 can be broken down to 2 squared, so you can take the 2 down. So log 3, 5 plus 2 log 3, 2. Log 3, 5 is Q. Log 3, 2 is P. Q plus 2P. Alright guys, so for number II captain, we are told to express 7.5 over root 3, okay, in terms of P and Q. Right. So, what does that tell me? Well, I don't like the look of this 7.5. Nothing against it personally, but I don't really like it in that form. So, we've got 7.5 here, and we're minusing root 3. Okay, why? Because remember, this is a fraction. Whenever we have a fraction, division in other words, we can represent it as minuses. I'm going to change the 7.5 to 14 over 2. Okay. And what do we notice? Well, this is another fraction. Right, so if we've got another fraction here, well, log 3, 14, log 3, 2, log 3, root 3. Okay, I'm just going to quickly put some brackets. Just don't want to get confused. Remember what we need to put it into. Log 3, 2 and log 3, 5. Those are going to be our final logs that we need. So from here, I can simply say, well, actually this shouldn't be 14, this should be 15. So from here, what can I say? Well, log 3, 5 plus log 3, 3 minus log 3, 2 minus log 3, root 3. What power must 3 be raised to get to 3? Well, that's 1. So, log 3, 5 plus 1 minus log 3, 2 minus, and the question here is, well, what is root 3? Well, root 3 is equal to 3 to the power of a half, which tells me that we have log 3 power half, and this can be brought down. So we bring this down. Okay, we are left with a half log 3, 3. And what power must 3 be raised to get to 3? Well, that's 1. So we can get rid of that. So what do we have now? Log 3, 5, log 3, 2. We know that log 3, 5 is Q. We know that log 3, 2 is P. So what do we get? Putting this all together, guys, we can say that Q, okay, minus P plus a half is our final expression. Okay? And that's your final answer here. So, how did we go about doing this again? We simply recognize that, look, they're trying to fool us around a little bit with the 7.5. You need to recognize that 7.5 is 15 over 2. Okay? But first off, we need to break this down into some kind of sum, which is 7.5 minus log root 3. 7.5 is 15 over 2, which is another fraction, so we can break that down again. 15 is a product, so we can break it down again. Remember, it's our Russian dolls. So we got log 3, 5, log 3, 3, log 3, 2. Okay, and we know that log 3 root 3, well, we've got 3 to the half, bring the half down. What power must 3 be raised to get to 3? 1. Okay. So, final answer is Q minus P plus a half. Alright guys, so for log 950, number triple I. Okay. What I can see here is that we have a 9 over here for the base of log. We have a very large number, 50. I'll say very large, semi-large. But this tells me something. What does it tell me? Just from a glance, this base is not this base. Two different bases here. Okay. So something tells me I've got to use the change of base formula here, guys. Okay, so log 3, or better yet, log 9 of 50. What's that going to give me? Log 9 of 50. Well, that's going to give me a value of log 50 over log 9. Now the question is, what base am I going to pick here? Well, bases over here are 3, right? So I might as well keep it 3. Even though technically speaking, I could use the base of log 56,000.235, right? So let's keep it 3. So, cool. We have converted the base, but we're not done yet. Okay. We're not done yet. Because I can convert this now. Log 350 over log 3 squared. Okay, which gives me log 350 over 2 log 3. Okay. What must 3 be raised to get to 3? 1. Okay. So we get a half log 350. So we're getting somewhere. Now we just need to figure out a way to get this 50 into some kind of expression involving log 3, 2 and 5. Well, that actually might be easier than we think. Because what we get here is a half log 325 times 2. So we got log 325 log 32, which equals what? What does 25 get to? What can we express 25 as? Well, we can express 25 as 5 squared. Okay, log 3, 2 there. Which means, using the power rule, 2 log 3, 5, log 3, 2. Okay, now we are getting somewhere, guys. So, what does that mean? We're going to get a half 2 log 3, 5, which was q, so 2q. Okay, and then plus p. Okay. P log 3, 2. Yeah. That's going to be a final answer there, guys. So again, looked intimidating at first, but really it wasn't too bad. We had a different base to what our P's and Q's are in. When we have a different base, guys, we just got to realize that it's asking us to do the change of base formula in most cases. Recognizing that, I say cool, change the base, we get this, and eventually we get this. All we had to do was apply our laws. That was it. Okay? And that's about it, guys, for number I. Alright, guys, so for number 3i, okay, this is a similar question to what we had before, okay, but in this case, we just got some different values to work with, okay, so let's do that. Okay, we've got a base of 2 this time, okay, so it says express log 263 in terms of P and Q. So, this is pretty simple. All we're going to say here, guys, is okay, log 263. What does that equal? Okay, actually, well, that equals 7 times 9, which equals what? Log 2 7 plus log 2 9. Okay. So that then means log 2 3 squared. Okay, because remember, 3 squared is 9. And we can bring things down. What are we looking for? Log 2 7, that's what we need. Log 2 3, well, how do we get 3? We're going to bring the 2 down. Okay, so therefore what we get, guys, is log 2 7 is q plus 2 log 3 log 2 3, sorry, so we get 2p here. That's the final answer there. Not much really to go through there, guys. Pretty simple and pretty easy as well. Alright, guys, so this is a pretty fun one, okay, for number II. So it says to find the sum of this log, okay, giving your answer in terms of a simplified form in terms of P and N. Now they do ask this, okay, this is something they ask, this kind of format. So if you haven't already, make sure to check out Minute Per Mark, where you can train under exam style conditions these types of harder questions, okay? So for now, there's only one type of question like this, but it's good to train different types. So, we need to break this down, okay? With the sum, r equals 1, going all the way up to n, okay, of log 2, 3 times 2 to the r. Okay, cool. So, what do we do? Well, we need to think to ourselves, what is this actually asking me? I can break this into, that goes on there, 23 plus, okay, log 2 2 to the r. Okay. So, what we have here, guys, is we've got the sum from r is equal to 1 up to n of log 2, 3, log 2, 2 to the r. Okay. So basically what this is saying is it wants a sum, okay, where r is counting from 1, 2, 3, 4, all the way to n of this sum. Okay. So this is a arithmetic series. Okay, just to put that graphically for you. Our A term will look something like this. Our B term, okay, our B term, or U2, looks something like this, but R is 2. Okay, that's what I'm trying to get at. It's a series. Okay, so this is where they're combining different parts of the syllabus together. So now what I need to say to myself is, right, what can I, before we go into P's and Q's, how can I simplify this down further? Well, I know I can bring this R down, okay, according to the power rule. Okay, R log 2. Okay, and what does 2 need to be raised to get to the power, to get to 2? 1. Okay, so what we have here is the following. And we know that log 2, 3 is P. But we're still a long way off. Okay, what we know now is that our equation is going like this: P plus 1, P plus 2, P plus 3, y, r, r, r. Okay, because we've got r is equal to 1 here. We've got r is equal to 2 over here. R is equal to 3 here. Okay. So, now, what is the sum of the series? Because remember, they want the sum. They're not just asking us to list out a series, they want a sum. Okay? So, we know that the sum of a series is equal to n over 2. Okay, this is back from the arithmetic series kind of section. 2a plus n minus 1 d. Okay. So, what does it tell me? Well, what is a? A represents U1, which is the first ever term, which is P plus 1. Okay. D represents the difference between each term, which is 1. Now, why have I said that? Because think about it, this is what our sequence looks like. We've got P plus 1, P plus 2, P plus 3, So, what do we need to do to P plus 1 to get to P plus 2? Well, we need to add 1. What about P plus 2 to get to P plus 3? We need to add 1. Okay. So therefore, our sum is n over 2, 2p plus 1, plus n minus 1. Okay, and all we have to do now, guys, is simplify. Okay, and when we do 2p plus 2 plus n minus 1, n over 2, 2p, what am I saying? 2p plus n plus 1, okay? And if I multiply the n over 2n, we've got 2np over 2 plus n squared over 2 plus n over 2, which gives me np plus n squared over 2 plus n over 2, which equals np plus n plus 1 over 2. Okay, if you really want to simplify this further. That's your final answer, guys. So this is a very interesting question because they've really weaved in a different section here. They've really weaved in a different section of that being arithmetic series, right? So specifically, what they've done, they've asked for the sum of this log, and what we've said is that, look, we can work that out, but we need to split it out first. I mean, we split this out. This is what we get. Log 2, 3. Okay, we bring the r down, r log 2. Okay. So, log 2, 3, we know that is p. And we know log 2, 2 is r. So this is our new sum. And we know that the way this actually looks, okay, is r is equal to 1, and that's counting up to n. So we got p plus r, where r equals 1 here. P plus r, where r equals 1, r equals 2 here. So if we have a series, our difference is 1 each time. Okay, so that's D. We know that A is P plus 1, that's our first ever term. Okay, just plug that in here. And why does that even matter in the first place? Because the sum of n is what this is. Okay. Plug everything in, simplify. We get to this as your final answer. Alright guys, so for number 3II, we are told that given log 2x is equal to 3p minus q, find the exact value of x, okay? So, what's that say? Log 2x what's log 2x equal? 3p minus q. Okay. So, from here, we need to find the exact value of x. Okay. So, what does that tell me? Well, we have a log type question. Okay, remember? Whenever we had like a ln, we'd raise to the power of e, right? So we have, say, ln x is equal to 5, e ln x is equal to e to the 5, x is equal to e to the 5. So in this scenario, if we raise everything to the power of e, that doesn't really work though. Because e to log 2x, we can't simplify that. But what we can do is we can raise it to 2. Okay. When we raise it to the power of 2, we get x is going to equal 2 to 3p minus q. Okay. Which means that if we get 3p minus q, we know as p, okay, what does p equal? P is equal to log 2, 3. Okay, and what does q equal? Q, okay, is log 2, 7. what does that mean? Well, that means that x is going to equal 2 to the power of 3 log 2, 3, okay, minus q, which is log 2, 7, okay, which gives me what? 2 to the power of log 2, 9, or better yet, 27, because 3 is going to go over the top, okay, 3 cubed, minus, okay, log 2, 7. So eventually what we get, guys, is x is equal to 2 to the power log 2, 27 over 7. Okay, which means that what we're going to get then is, look, we've got 2 log 2 here, so therefore x is going to equal 27 over 7 as your final answer. Okay, so how did we do that, guys? Well, again, what we did was we raised our values, okay, to the base of 2. Okay, we put them on top of the base of 2. And we know that 2 log 2 of something, 2 to the power of log 2 something, is going to equal that thing. In this case, it was x. Then we just plugged in p and q, applied our log rules. 3 goes over to get 27 there. So log 2 27 minus log 2 7. 2 to the power of log 2 27 over 7. So x is equal to 27 over 7 as your final answer. Alright guys, so for number IV here, it says to solve the equation 2 log of 2y is equal to q plus 3. Okay, and it wants us to give it in the form of a root b. A and b are integers to be found. Cool. So 3IV, 2 log 2y, okay, is equal to q plus 3. Well, what do we know here? Starting off, we can say that our 2 here can be raised to the power, okay? It can be raised. So log 2 y squared is going to equal q plus 3, okay? We know that first and foremost. Now, what we have is 2 variables, or so we think, okay? Because what I'm going to do now is I'm going to say, look, we got a log here. I don't like that log here. So I'm going to raise it to something that's going to get rid of that log and give me y squared. And what is that something? That something is going to be 2. Okay. So I get y squared is equal to 2 to the power of q plus 3. Okay. Now what is q? Remember, I don't want 2 unknowns here. Well, q, if you recall, q is log 2 7. Okay, so y squared log 2 7 plus 3. Now, according to our laws of indices, I can break this down even further. I can say y squared is equal to 2 log 2 7 multiplied by 2 to the 3, okay? So when they're multiplied, the exponent's going to add, right? So therefore, y squared is equal to 7, okay? 7 over there times 2 to the 3. Okay, what's 2 to the 3? Well, 2 to the 3 is 8. So y squared is going to equal to 7 times 8, which is 56. Now, they want it in the form a root b, which is interesting, Because what that entails for us now, guys, if they want it in the form a root b, then what have I got to say? Well, if they want it in that form, then we're going to have to use surds. So y root 56. Okay, now how can I break 56 down? So 56 is a product of its prime factors. Okay, 2. Okay, and we're doing that by 2 here. What we've got is what am I doing? Yeah, that's going to be 28. Sorry, a little brain fart there. Yeah. Okay, we've got 2 there. And what else can we break it down to? Well, one thing that might just be easier to do is, now I think about it, we had 7 times 8 here, so I can just plug that back in, right? Highest factor, prime factor, that is 7 times 8. Because remember, that's what we do for surds. So really that transforms now into 7 times 4 times 2. Okay, because now I'm breaking the 8 down into its prime factors. Okay, which gives me what? Well, that is root 7 times 2 times root 4. Okay, which means that y is going to equal to 2 root 14. Okay. Again, if you haven't watched the surds video, make sure to do that. But essentially, it's the fact that I'm breaking it down into its prime factors. Highest prime factor, okay? 56, that was 7 times 8. And for 8, that was 4 times 2. Okay? So eventually we get 2 root 14. Now, why is that plus and not minus? Because remember, if we have minus root 14 here, that's not going to work as y, because remember, this is our original equation, and we cannot have a negative inside the log. Okay, so it's going to be positive 2 root 14. Alright guys, so for number 4a, it says to find the exact solution of 3 to the 4x minus 1 is equal to 20, and it wants us to give our answer in this form. Okay, so by now you should be able to see the pattern. To answer a question like that, what I need to say is, okay, listen, we've got a exponential equation, so I need to take ln or log of both sides to drop the 4 down, okay, so I can solve for x. The way you do that is you got to figure out what base to do. Now, because we're to a base of 3, in this case, it simply makes sense to raise it to that base, I think at least. Okay, because they want the answer in the form of log 3b. As I said before in the introduction, you could technically do ln 3 4x minus 1 is equal to ln 20, because that'll give you 4x minus 1 is equal to ln 20 over ln 3. And that you could still technically get the answer. But they want it. They want it with the base of 3. Okay, so I'm going to keep it like that. Which means in my case, what I'm going to do is, considering we have a 3 here, I'm going to do log 3. Okay, so log 3, 3 4x minus 1, okay, is equal to log 320. Okay, and power rule, we can bring this down. So 4x minus 1 is going to equal log 320. Now, why did I do that? Because when you bring this down, we're stuck with log 3. Okay, what does 3 need to be raised to get to 3? 1. So it's just 4x minus 1 times 1. That's why I've done that. So we get 4x is equal to log 320 plus 1, which means that x going to equal 1 plus log 320 over 4. Okay, that's the final answer for number A, guys. So let's go over how we did that. First thing you need to recognize is that whilst we could do ln as our base here, or e as our base, I should say, they wanted it as 3. So that's why I stuck to 3 when taking the logs of both sides. Okay. All we had to do was do that. Recognize that log 3 is just 1. So therefore it's an easy case of doing 4x minus 1 is equal to log 320, which means that x is equal to 1 plus log 320 over 4. Alright guys, so for number B here, they want us to show that the answer can be written as log 3k over 4, okay, and to state the value of the integer k. So what this signals to me is it only being 2 marks, we just have to rearrange our previous answer basically. Okay, so let's think about this. Well, we know that x is equal to log 320 plus 1 over 4, okay, log 3k. So that means that this needs to get to log 3k somehow. Which means it must become 1 logarithm. Which means somehow this 1 must transform into something to give us that 1 logarithm. And I think you know the answer now. We need to transform it to log 3. Okay, which means that therefore x is going to equal to log 360 over 4. Therefore k, why did I put 4 there? K is going to equal 60. So how do we do that, guys? Again, we simply did some pattern recognition, and as you can see, okay, if they want it in this form of log 3k, we cannot have this as our form. That must mean that log 320 plus 1 is going to equal log 3k, which means that 1 must be a logarithm somehow, because when we combine it with 20, we're going to get our k, and that's what we did. Log 3, because 3 has to be risen to 1 to get to 3, so therefore the answer of this is 1. Okay, so boom, product rule there, or logarithm product rule, 20 times 3, 60, k is equal to 60. Alright guys, so for number 5 here, we are told that given that 4 to the a times 8 to the b is equal to 2 to the 3a plus 5, express b in terms of a. Okay, so this is actually more of an indice type question in many ways. As you can see, we don't necessarily have to use logarithms here, but let's see what we can do. Okay, so for number a, I've got 4 to the a. Okay, and we've got 8 to the b. Okay, 2 to 3a plus 5. Okay, what that means is that simply, can we break this down into, look, there's a few ways we could do it. You could do it in terms of logs actually, but I think what's easier is simply to recognize, guys, that 4 is equal to 2 squared, so therefore we've got 2 to the 2a. We also know that 8 is equal to 2 to the 3, so therefore we've got 2 to the 3b. So now we have the bases all the same, and when we've got all the bases to the same, we can drop them. We can drop the base. Okay, which means that 2a plus 3b is equal to 3a plus 5, which means that 3b, okay, is equal to a plus 5, which means that b is equal to a third a plus 5. Okay, and that's going to be the final answer there. So what do we do here? All we did here is we simply recognize that, look, 4 and 8 are just products of 2. Okay, 4 is 2 squared, 8 is 2 cubed. Okay, and we've got a 2 here as well. So if we get the same base, we can drop the base and simply solve for the exponents. That's what we did. So we get a third a plus 5. All right, guys. So for number b here, for number b, we are told that given also that 2 to the 4a over 16 to the power b is equal to 16, we need to find the values of a and b. Okay. So this is going to be similar to the one before, because 2 to the 4a. Okay, then we've got 16 to the what? 16 to the b is equal to 16. Similar to before, 16 can be represented in terms of 2. How? 2 to the 4a over 2 to the 4b, okay, which equals 2 to the 4. So what does that tell us? Well, 2 to the 4a is equal to 2, 4 plus 4b. Brilliant, easy. We can drop the bases. So 4a is equal to 4 plus 4b, okay? Which means that, let me see here. 4a is equal to 4 plus, which means that a, we can actually divide it by 4 here. So equal to 1 plus b. B is equal to a minus 1. So therefore, I can say that a third a plus 5 is equal to a minus 1. A over 3 plus 5 over 3 is equal to a minus 1. Okay. And then, what does it tell me? Yeah, take out the 4. Okay. So a over 3 plus 5 over 3 is equal to 8 minus 1. Okay. A plus 5, 3a minus 3. A plus 8 is equal to 3a. 8 is equal to 2a. So therefore a is going to equal 4. Okay. So if a is equal to 4, guys, what's b going to equal? 4 minus 1, which equals 3. Okay. So again, just following on from the same concepts as before, guys, we just have to recognize that if we put things all in the same base, then we can solve the exponents. And in that case, simultaneous equations for b and a to get a is equal to 4 and b is equal to 3. All right, guys, so for number 6, we are told that a curve C has the equation of y is equal to log 3 2x plus 1. Okay, x must be greater than or equal to 0. We are told to complete the table below, giving values to 4 decimal places when appropriate. So, what does that mean here? Well, that's pretty easy. Okay, this is going to be a calculator type question, unless they otherwise specify. And all we have to do, guys, is just plug in our values into the calculator, okay? And what does that give us? So y2, plug that into the calculator, into this equation. That's going to give us 0.6309. y4 over here, plug that into the calculator as x. What we're going to get is 1.2619. Okay, then y6 over here, plug that in. We're going to get 1.6309. Okay, these are going to be the final values. Okay, so how do we do that? Simple enough, no real explanation needed. Just need to plug in the values, and that's how you get it. Alright guys, so for number B here, we are told to use the trapezium rule to find an estimate for this, okay? So we basically were just setting this up in the beginning. This is like 1 mark, okay? But now this is where we really have to kind of apply knowledge from other sectors into our equation, okay? Into our formulas and whatnot in order to find the answer that they want. So first off, what is the trapezium rule? Well, the trapezium rule, as you remember, is basically the fact that another way to find the integral, okay, this is heavily, I did applied maths in university, so I did this a lot, is that you can approximate mini trapeziums, okay, along the curve, okay? And the sum of those trapeziums is going to give you the integral. It has to. Okay, but obviously these are usually estimates because it's an approximation. Okay, let me put that little work of art there. So this obviously is going to have some kind of formula, right? What that formula is, as you recall, is h over 2. Okay, then we got y1, then we got 2 times the sum. In fact, let me just write it manually. y2, y3, y4, y5, y6. Okay, then you got y7 at the end there. Right, so when we do that, guys, what do we get? Well, h b minus a over n. Okay, what's b? 3. What's a? 0. What's n? Well, our n, okay, is actually 6. Okay, so 3, 4, 5, 6. So now I've put it up to y7 here, but obviously for the actual number of trapeziums, okay, we're going to have 6, okay, because it's from y1 to y7. Okay, so if I do b minus a over n, that's going to give me what? 3 over 6, which equals a half. So a half divided by 2 is going to equal a quarter. Okay, so therefore what we have is a quarter, okay, of 0 plus 2, and from there we're going to have y2, which is 0.6309, y3, which is 1. Okay, then after that we've got y4, 1.2619, okay, then it's 1.4650. Okay. Then after 1.4650, we're going to have 2.5, where x equals 2.5, which is our y6, so 1.6309. Okay, and our final one here, is 7. The 7th one. Okay, so that is 1.7712. Okay, and when we find the sum of that, or the value of that, that's going to give us a value of 3.437. Okay, so again, classic mistake is the n, right? N here is 6. Okay, because what we're really talking about is the trapeziums here. All these values, I mean. So that's why we've done that there, even though technically we have 7 entries. Okay, so that's just something to keep in mind. And so knowing that, 3 over 6, half divided by 2 is a quarter. Then we just plug in our values, 3.437. Alright guys, so for number C, we are now told to find an estimate for this, given our answer in part B. Okay, this was our answer in part B. So, first things first, if you are not smart with this, you could waste a lot of time. Okay, but we're going to be smart about this. What relationship does this have to this? Well, 4x squared plus 4x plus 1, okay, is 2x plus 1 squared, right? It is 4x squared plus 4x plus 1. So what does that tell me, guys? Well, that tells me that the integral of this is the same as saying I forgot the log, that's important. Okay, it's the same as saying this. So now what do we do? Do we expand again? Do we integrate normally? You know, power rule plus 1 divided by 3? No. Because using our log power rule, we can bring the 2 down as a constant. So what we've got is 2 times the integral. Okay, log 3 2x plus 1 dx. And we just found this there. Or better yet, we found this, the whole integral over here. Okay, so what I'm going to do is I'm going to plug this whole thing, not this because we round it, but just to make it easier when writing, I'll put this in. But you want to plug the whole thing in. So we get 3.437. Okay, obviously when actually doing it on the calculator, you plug the entire thing in, and that is going to give us a value of 6.87. They say to how many decimal places? Estimate. 7. Let's do that. 6.8743. They haven't specified. Okay, now how do we do this? We simply recognize that, look, this here is the same as 2x plus 1 squared. Okay, which means that according to our log rules, we can take down a power. Take down a power, we're multiplying it by something we already found the value for. Plug it in, we get our value. That is it. Alright guys, so for number 7 here, we have a curve with an equation of y is equal to 2 times 3 to the x minus 6. We are then told to sketch the curve. Okay, so all this is, guys, is demonstrating that you know how to sketch, which is one of the key specifications. Okay, and all you need to remember is our key points from before, where for the asymptotes, okay, for the asymptotes, remember, at least for, say, a to the x, okay, if you have something like this, that our asymptote is the x-axis, okay? So that's the first thing. Okay, well, obviously we're minusing 6 here. And we're always going to intercept at 0, 1, okay? So all we have to do now is just apply, use that as a general framework, but now apply it a little bit more tailored to this, okay? So what I'm going to say here, and this is the same as drawing any graph, our intercepts, okay, I'm going to say at x equals 0, what do we get? Well, that's 2 minus 6. So y is equal to 2 minus 6, which is minus 4. So therefore, 0 minus 4. Next, at y is equal to 0, what happens? At y is equal to 0, 2 x minus 6 is equal to 0. 2 times 2tx. 2tx is equal to 6 over 2, which is, well, 3. Okay, so what does it tell me? That x is equal to 1. Okay, no surprise there. Well, sorry. That's my fault. That's our intercept there. And as you can see, for our y-intercept, this time it wasn't 1, okay? It wasn't 0, 1. This time we got 0, negative 4, because we're shifting here. Okay, so an important point. So this is our other intercept, which is 1, 0, okay? What about our asymptote? Well, remember, okay, what our normal asymptote was before. Our asymptote before was y is equal to 0. Okay, we can never approach y equals 0 normally. Okay, that is for this. So if we take away the 6 for a second, the asymptote for 2 times 3 to the x is y equals 0. We can't ever approach, okay? We are never ever going to get to y equals 0, but we're approaching it. The minus 6, all it's done is that it's shifted down. Okay. So what does that tell me? Well, it tells me that minus 6 must be our new asymptote. Because if this one is 0, and we're minusing 6, therefore our new asymptote is going to be minus 6. Okay. So now I've got the building blocks for my graph. So let's put this on an axis, because they all come to life now. So putting this on a graph, guys, I want to be meticulous with this. Because we're going to have negatives. Okay. Maybe do a bit here. 0. Minus 6. Okay. So in fact, what I'm going to do, just to label it a little bit nicer. Just going to put here y equal to minus 6. Okay. That must mean that 0 minus 4 is going to be around here. Okay. So, and our intercept here, maybe make that a little bit more around here. Well, that's 1 actually. So if I'm doing this a bit more to scale, we're looking at something a bit, yeah, more around here. So 1, 0. Okay. Got Y here, X here. And we are just going to gently draw the graph going up, okay? Where y equals 6 is our intercept, our asymptote, sorry. We can't ever touch it, and we're going to come up gently. We're going to pass through 0, minus 4. We're going to go through 1, 0. And we're going to keep going. Okay. So that's the final answer to number 7A, guys. Okay, so all that was simply showing that you understand how to sketch the graph. And the trick with these is to draw it like you would any other graph. Okay, like in the transformation section. It's just a case of asymptotes, intercepts, and just having that foundation and then allowing yourself to draw it neatly. Don't worry about going too much into scale or anything like that. Alright guys, so for number B, they say that a line with the equation y is equal to 5x plus 2 meets the curve at point P. And it wants us to show that the x coordinates of P satisfies this equation. And that equation is 2 times 3 to the x is equal to 5x plus 8. Okay, so all you have to do, guys, is let 5x plus 2 equal this. Okay, so let 5x plus 2 equal 2 times 3 to the x minus 6. Okay, so what does that mean? Well, what does that mean? Well, 5x then is going to equal 2 times 2 to the x minus 8. Okay, which means that 5x plus 8 is equal to 2 times 3 to the x. That's exactly what they wanted. Now for number C, guys, they want us to verify that x equals 2 is a solution for 2 times 3 to the x is equal to 5x plus 8, and hence state the coordinates of P. So, to do this now, guys, what we have to do is simply say, okay, cool. Well, for x equals 2 to be a solution, what we need to do is we can't just plug it in, okay? Because if we just plug it in, then we're not actually verifying anything. So how do we actually go about verifying this? Well, the way we're gonna go about verifying this, guys, is using the fact that they've already given us this, right? So what I'm going to say is right hand side. Okay, I'm going to say if x equals 2, right, then 2 to 3 times 2 minus 6 gives me what? Sorry, take away the 6 there. 2 times 3 squared is going to give me 18. Okay. Now I'm going to say that if the left hand side is equal to the right hand side, that must mean that 5x plus 8 is going to equal 18. So 5x is equal to 10, x is equal to 2. Okay, now remember, I haven't just plugged it in and been like, look, it's obvious, which it is. But you have to be a bit more mathematical with it, and that's what I've done. So I'm not assuming they're equal now. So I said right hand side, okay, 18. So I said if they're equal, 5x plus 8 is equal to 18, so x is equal to 2. Okay, cool. So that means that therefore x equals 2 is a solution. Okay, that's cool. So therefore for p, what are we going to do? We're not going to plug it in to our equations here, but what we are going to do is plug it into these, okay? Because these are original equations, these aren't, okay? So I say at x equals 2, remember this is in this section, I'm going to just pick the easy one, and that is 5x plus 2. So we've got 5, 2 plus 2, which equals to 12. Therefore, p is equal to 2, 12, okay? That's the answer. So guys, this one, relatively easy, if I'm being honest. We had to draw the graph, which took time, so that's why I was higher marks. But the other ones were 2 marks, because they were both very simple. All it came down to was having a bit of like mathematical method. You can't just plug it in. Have a bit of mathematical method there. Verify that x equals 2 is a solution. Plug it in to one of our original equations, not our new equation here. And doing that, we get 2, 12 for p. Alright guys, so for number 8, we are given that 4 to the x times 2 to the x plus 3 is equal to 512. We're told to show that 2 to the power of 3x plus 3 is equal to 512. Okay, so the way we go about doing this, guys, is what we're going to say is, okay, look, just like before, can we get these all in the same kind of base, right? And I think we can. Well, that's going to be for b at least. This is going to be the starting point. So 2 to the 2x times 2 to the x plus 3 equals 512. Therefore, 2 to 3x plus 3 is equal to 512. Very simple. That should just be 1 mark, if being honest. Okay. And now for b, to find the value of x, we need to break 512 down. Okay, so we break 512 down. What do we know? Well, we know 512 is equal to 2 to the 9. Okay. Which means that 3x plus 3 is equal to 9. Which means that 3x is going to equal 6. Which means x is equal to 2. Okay, that's the final answer there. So remember, very simple question, but I've put it in because these ones do come up. At least more so for international, but for UK as well. So what we're going to go through now is these ones are for both for paper 3 international and UK. The reason why I've only put 2 of these ones in, even though they represent a large proportion of the UK syllabus, is because there's not really that much to it. I feel it would be too much repetition if I just, like, unnecessary repetition if I just did a bunch of these. They're pretty like, after going through both of these, you'll see exactly what I mean. They are pretty simple once you kind of hone in on the method. But what I wanted to do was introduce the UK people to questions that can still be tested because it's still part of the spec, but maybe won't come up as much, but can catch you out. So that's why we've got some sporadic questions that are for paper 2 and for UK as well. But now what I'm going to do is go through paper 3 and the ones that primarily show up in the UK. So that way, if you're UK in Excel, you're set because you've got all the other questions and you know how to do the graphical ones. And if you're international, you're set because you've got the paper 2 ones, which we've just gone through. But when it comes to paper 3, you're also going to be set. So let's go through these questions now. Alright guys, so for number 9, we have a classic kind of paper 3 or UK at Excel question, okay? for the AS. So what we've got here is a population of bacteria, okay? And it's modeled by P is equal to AB to the power T, okay? Now, obviously, with exponential graphs, the reason why we graph it like this, as you may recall from the Log Lab web app, is that it's just a pain to graph something like this. So it makes a lot more sense to just do it in terms of logs. So we are told for number A to find the equation of the straight line in the form log 10p is equal to mt plus c. Okay, where m and c are constants to be found. So how do we go about doing this? Well, what we need to say, guys, is I'm just going to let a y equal log 10p. Okay, now why am I doing that? I'm doing that because by letting y equal log 10p, I'm recognizing that log 10p, okay, this is all just a function that we're used to. There's no need to complicate things. And in that same note, we can find m. Oh, we need to find an equation, so we do it as we normally would. M is going to equal rise over run, so 3.3 minus 2.1 over 10 minus 2, which gives me 1.2 over 8, which gives me 0.15. Okay, I can then say y minus y1 equal to m x minus x1. So y minus y1, let's do y1 as 2.1. Y minus 2.1, okay, is equal to 0.15 x minus x1, which is 2. So y minus 2.1 is equal to 0.15x minus 30. So y is equal to 0.15x. Okay, then we're going to add, why have I put 30 here? 0.3. Okay, so next I'm just going to add this up. So what's going to give me, guys? That's going to give me plus 1.8. So therefore, remember, we can't just use y even though it's easier. Log 10p. In fact, sorry, I should actually change this. So therefore log 10p 0.15 t plus 0.8. Okay. That's the final answer for that question, guys. Now again, they were trying to confuse us because they're trying to make it seem like this is more complicated than it actually is. It's really not. Very simple stuff. Just find the gradient, and then you can find the equation on the line. Okay, I used x and y, but I just replugged it in. So simple as that. Alright guys, so for number B here, it says to hence find the values of A and B, each to 3 significant figures. Okay. So, A and B. Well, remember, P is equal to ABT, AB to the power T. Okay. So the way I'm going to do this, guys, is I'm going to do logs of both sides. And then I can correspond it to this. So I'm just going to say log, actually. Log P is to log ABT. Which means that log P is equal to log A plus log B to the power T. Which means that log P is log A plus T log B. Okay? So, log P is equal to log B times t plus log a. Now, as you can see, guys, this is pretty much in the same format as what we had here. Okay, so therefore, all we have to do now is match it. So therefore, log a, okay, what is log a going to give us? Well, log a is going to equal 1.8. So therefore, a, remember this is 10. That's our base. So what power must 10 be raised to get to a? Well, that power is 1.8. So therefore, a must equal 10 to the power of 1.8. So therefore, a is going to give us 63.1. Meanwhile, okay, on the other hand, log b is going to equal 0.15, which means that if I'm writing this more thoroughly, log 10b, what power must 10 be risen to get to b? Well, we know that power is 0.15, so therefore b is equal to 10 to the power of 0.15, which means b is going to give us 1.41. Okay, that's going to be a final answer for that. So how do we do that? Again, p is equal to ab to the power t. Okay, so if we find the logs of these, we do the log function on both sides, and we just do some algebraic manipulation, we can get to our final answers by recognizing that log 10a, okay, our base is 10, so therefore we have to put that as the base for 1.8 being the exponent, right? So therefore we get 63.1 for a and 1.41 for b. Now for number C, guys, it says that using this model, estimate the population when t is equal to 20. Okay, so what does that mean? Let's put C here. At t is equal to 20, what happens? Well, log p is equal to 0.515, sorry, 20 plus 1.8. Okay, so it means that log p is going to equal 4.8. If we simply now raise that to the power 10, 10 to the 4.8, which is roughly 63,096, okay? That's your final answer there, guys. So, what did it say? Yeah. So that's basically it. Plug it in, we estimate it. And if they wanted it to, you could maybe round it up if they wanted it to some other significant figures. Always watch out for that, but I'll just put it here because that wasn't mentioned. Okay, so perfect. Let's get on to the next question now. All right, guys. So for number 10, we're told that the concentration of a drug in a patient's bloodstream is modeled by C is equal to AE to the negative KT. Okay, and again, we've got a graph here, and it's modeled, obviously, it's exponential, it's E, and it's ln. Okay, cool. So this, now, what we need to do is find an equation of the straight line, which is not surprising at all. That's usually what they want. So what do? We're simply going to say, what I'm going to say, let ln C equal Y, let T equal X. Okay. M, what's M equal? M is simply going to equal 3 minus 1. Okay, rise over run over 4 minus 12, which is equal to 2 over minus 8, which gives me negative a quarter. Okay, so y minus y1, 3, which is 3, negative a quarter, x minus x1, which is 4. Okay, so y is equal to y minus 3, negative a quarter x plus 1. Okay, which means that y is equal to negative a quarter x plus 4, which means, plugging things back in, ln c negative is equal to negative a quarter t, okay, plus 4. And that's the final answer for number A. So it's pretty much exactly what we did in the other question, guys. Simplify things down for yourself. And that's why it's 2 marks. It's extremely simple. Simplify it down and find the gradient, equation line, you're sorted. Alright guys, so for number B here, it says to hence show that K is equal to 0.25 and find the exact value of A. Okay, so remember our original equation is C is equal to AE to the power negative KT. Cool. So first things first, using a bit of pattern recognition, this is a bit similar to this, okay? But we're not finding A and B, but we are trying to find K, which means we're going to expand this out via our ln functions and then correspond it, okay? So if I say C is equal to AE to negative KT, ln C is equal to ln AE to negative KT, which means that ln C is equal to ln A plus ln E to negative KT. Okay. Now, what does that mean? Well, KT can be brought down via the power rule. So ln C then is equal to ln A, okay, minus KT ln E. And what's ln E? Well, ln E is 1. So ln C is equal to ln A minus KT. Okay, so therefore ln C is equal to negative KT plus ln A. And so how do we find K now? Where does K come from? Well, think about it. This, corresponding it, is the same equation. And so therefore, if we've got negative a quarter here and we've got negative K here, that must mean that K is equal to 0.25, okay? Which means that therefore ln A, okay, based on the fact that the same equation, is going to equal 4. Okay, and what does it want us to show? Exact value of A. So A is going to equal e to the 4. Okay? And then that's going to be the final answer to that question. So just to go over that again, the number B, we simply had to correspond it. Okay? So C is equal to AE to negative KT. Do ln of both sides. And you'll see by comparing the equations, K is 0.25, so A is going to equal e to the 4, sorry. Now for number C, guys, it says to find the concentration of the drug 6 hours after injection, given the answer to 2 decimal places. Okay, so 6 hours after. So remember, T is represented in terms of hours. That's important to recognize. Sometimes they can make it in minutes, but you have to convert it. So always double check that. Okay, so 6 hours. That's pretty simple. We just have to plug in T. So C is equal to AE, okay, to the negative 0.25 T, okay, which means in this case the concentration of 6 hours is e to the 4, okay, times e to the negative 2.5 times 6, okay, and when we plug that in, okay, what we're going to get is 12.18 milligrams per litre, okay? Two decimal places. So, they want the exact value, and obviously we use our exponent laws to do that. But considering they wanted it to two decimal places, we simply plug it in. So pretty simple. For number D here, guys, it says to give one reason why this model may not be reliable for larger values of t. Now again, this comes back to what we were saying right at the beginning, okay, when it comes to interpreting graphs, okay? So, remember that our equation here, okay, c is equal to e to the 4, okay, and it's actually over to the 2.5 t, okay, because we have that negative, right, over here. So, what does that tell me? That tells me that as t gets bigger, okay, as it tends towards infinity, c is tending towards 0, okay? Because the denominator is getting bigger and bigger and bigger. So, what we know is that for a very large t here, okay, the model could give a very small non-zero concentration. Doesn't match reality, okay? So that's essentially what I'm saying, is that as t is increasing, our concentration is essentially getting extremely small, okay? And that concentration could very well not match reality at that, at that massive value of t. Okay, so that is a potential constraint there.